Hello, in this video we're going to be going over compound events and counting. This is a subtopic in probability. And I'm going to start you off with an example. 3 fair dice are rolled. We're going to find out the probability that exactly 2 of the rolls show a 1. So we need the probability of rolling a 1, and an X. Or a 1, an X and a 1, or an X, 1, 1. So let's figure that out. So if the probability that the first roll shows a 1, again, this is going to be a dependent, so we're going to have to do it case by case and then multiply them together. So we're going to start off with the first roll. The probability that the first roll is a 1 is 1 in 6, because there are 6 options. That's the total outcome, over the good outcome, which is the rolling a 1. And then we also have the probability the second one is a 1. So these are dependent events, so I'm going to multiply. And then it's going to be another times 1/6, because you roll a die twice. That doesn't change based on the previous roll what the next roll is going to be. And then I need this third one to be something that's not a 1. So it could be a 2, 3, 4, 5, or 6. Well, the amount of good options, I was 2, 3, 4, 5, 6. We have 5 good options over the 6 possible different rolls that it could be. And then also I need to multiply by the order. I could roll an X, a 1, and a 1, or I could roll a 1, X, 1. X is just the 2, 3, 4, 5, 6. So I need to multiply this by 3. And this right here will be our answer. I can simplify it up a bit. And I'll get 32 times 2 is 64. 5 over 64. Now we're going to move on to the next example. Hank can hit a bullseye 1 in 3 times. If Hank tries 9 times, what is the probability that exactly 3 of them will hit a bullseye? So we'll say that's a hit. Exactly 3 of them hit, and that means that exactly 6 of them miss. Okay, so I have to figure out the probability of getting a hit and cube that. I have to define the probability of getting a miss, cube that, and then I also have to figure out the order, because getting a head, miss, head is different than that. So I need to include all of those cases. So we're going to start with the head. So we can hit 1 in 3 times. That's going to be 1/3. And then we're doing it 3 times. So it would be 1/3 times 1/3 times 1/3, because this is the probability of hitting once and hitting twice and hitting 3 times. So it's the probability of hitting once times the probability of hitting twice times the probability of hitting 3 times. And then we're also going to have the probability that it misses exactly 9 times. So if it hits 1 in 3 times, then that means it must miss 2 in 3 times. So that's 2 over 3. And then we have 1, 2, 3, 4, 5, 6 to the 6th. And then we need to do order. So a few episodes ago, I did a little bit of this, and we're going to go a bit more in depth right now. So if I have the word abaca, which is of course a type of dog, definitely not messing with you. The amount of ways that I could write this, we have 4 options for the first one, the A, B, C, or the other A. You can imagine we cross one out, then we have 3 options for that one, and then 2 options for the next one, and then we're left with only 1 option. And so that would be 4 factorial. But we double counted the case where I have B, C, the first A and the second A, and then B, C, the second A, and then the first A. These 2 words are both baka, but we counted them twice. So I need to divide by 2, because every time the arrangement of A's will be off. And it's really 2 factorial, because when I have 2 letters, there's 2 ways to arrange it. But if I have 3 letters, for example, A1, A2, A3, There are 6 ways to do it, which is 3 factorial. I'll just go quickly and show you. A3, A2. And then if we start with A2, we can have A1, A3. And then we could do A3, A1. And then if we start with A3, we could have A1, A2. If we start with A3, we could have A2, A1. That's 1, 2, 3, 4, 5, 6 ways, which equals 3 factorial. So we could see over in this example, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 factorial divided by the 3 factorial for these 3 times the 6 factorial for this. And that right there is equal to 9 choose 3, which you could also write as 9 choose 3 or 9 choose 6. They're the same thing. That's a little bit of combinatorics for you. And so that right there is going to be your answer, which seems like a pretty small number if I'm looking at it. Or maybe not too, a little small. Okay, now on to the last problem. This problem is also a little sneaky. It's adding something new to the table. In 6 rolls of a standard die, what is the probability that the same number will be rolled exactly 5 times? So we're going to have the probability that we roll a number 5 times, 4, 5, and then we roll a different number. We'll call that y. So the first roll, we could roll any number. So the probability that you can roll any number, well, you have 6 total options over these 6 good options over 6 total options, so that's 1. And now after this first roll, we'll say it's a 4. Now we know that we have to get a 4. So now for these next 4 ones, we have a 1 and 6 because we have to roll 4. There's 1 way to roll 4 and 6 ways to roll. We have a 1 and 6 option of getting a 4. And so 1 and 6 times 1, 6 times 1, 6 times 1 and 6, that's 1 to the 6, 1 6 to the 4th. And then we have the y, we have to multiply, we have to multiply by whatever the probability of getting a y is. So if we've chosen, for example, a 4, then we can still roll a 1, 2, 3, 5, 6, which gives us 5 out of the 6 total options. So we're going to multiply by 5 over 6. And then we also need to find out the order of this. So we could have the y over here, we could have the y over here, over here, over here, over here, and over here. And that covers all of our examples. So it'd be 1, 2, 3, 4, 5, 6. So we need to multiply by 6. And that right there is going to be your answer. And we can even simplify this a bit. I think it comes out to be 5 over 6 to the 4th, which I think is 1,296. Anyways, there you go. That's how you solve compound events in counting. Thank you much for watching, and goodbye.